Okay, the vertical line test tells us if a graph is that of a function or not. And if your vertical line, like this blue line here, touches twice, that means that it's not a function. Well, let's make sure you understand why, though. Okay, because otherwise it's just a dumb thing. Does the line touch twice, yes or no? I want you to get why it tells you if it's a function or not. Okay. With a function, do you remember that there's things called inputs and outputs? At this spot, just the one I got circled here, the input was what? Which was the input again? The x, good. And which x did I use? 1, 2, 3, 4, 5. What was the input? Say it if you know it. 1, okay. That input was 1. The output is how high it went. It looks like it's about 1.3. So this spot right there is 1, 1.3. Do you get that I had an input of 1 and an output of 1.3? But here's the thing. We had an input of 1, and we also got an output of negative 1.3. 1, negative 1.3. Do you get that one input had two outputs? That's the definition that you're breaking on a function. Is a function, if you have one input, you can only have one output. Okay? Think of it as like a graph of where you are in time. Let's say this is time 1 second, time 2 seconds, time 3 seconds, time 4 seconds. Where you are in time is a function. Because could you be here at second 1, here at second 2, and here at second 3? If you're moving, you know, like is this all of that possible? Yeah, you can be at different places if you're moving, different places, different times. But can I do this in the real world? No, because at input of 3, I have an output of two different things. I'm here and I'm here. That's impossible. Okay, so where you are right now in the room is a function. Because you can't be here and there at the same exact time. All right. So that's why we have this thing called the vertical line test. And it's really quick and easy. You just look at the graph and see, would it touch twice or not? All right, here's a graph. You tell me, would it pass the vertical line test? Yes. Because you pick any input, like let's say a straight up and down line. I kind of like using one of these for that. Straight line. There we go. Use a blue one. Nice straight line. Okay. This line right here, at input 0, it isn't anywhere. At input 1, it's right there where they touch. If I have any one input, it only has one output. It never went back on itself. All right. This one is a different question. This could not be where you are in time, but is it a function? How do you tell if something's a function or not? Every input you put in has to have one output. Does this pass the vertical line test? All right. All right. I think you're interpreting the definition wrong then. In fact, I probably said it wrong. Every input can have at most one output. So the point is, this is a function. And why? Again, that vertical line test is really powerful because it even handles situations like this. How about this? I'll ask a simpler question. Does this pass the vertical line test? Yes or no? Yeah, because it never touches twice. That's an empty spot on the line. That's what that hole represents. And it's never touching twice. It's only touching once, so that's a function. Now the thing here, I said before, this could not be a graph of where you are in time because in this little zone there was time where you didn't exist. Okay, and then you can't exist here and then not exist and then exist again. This couldn't be a graph of you in time, but it is a function. It's okay to have this for a function. So there's a really simple rule for the first few. If it passes the vertical line test, it's a function. All right, let's do another one. Function or not? Nope, not a function, because it doesn't pass the vertical line test. You pick an input like, let's say, 6 over here. It's got two outputs. Let's say output of maybe 3 and -2 or something. It's got two outputs for one input. Can't do that. All right, enough of that. Let's move back to this. Here it is in words. Some people really like to see it in words, and so that's why we provide these. So if I'm saying it with examples and you're not understanding, you can look at it in words. All right, but this is other ways you can represent a function. You can have a graph for it. You can have ordered pairs. You know, a bunch of 2, 3 is in the function and 4, 6 is on the function. Those are ordered pairs. A table of values, that's just ordered pairs in the table. And arrow or mapping diagram. To be honest, I don't think I've ever seen a mapping diagram, but anyway, we're moving on. Example 1. When a function is defined by an equation, you can simply replace each x with the value and then evaluate. So for instance, if f of 8 is what we want, we stick 8 in for what? X or y? X. All right. So you're just going to stick an 8 in for x. You put it right there. Notice I'm putting a parenthesis around it because I know that when you get negatives involved, that parenthesis becomes really important. Frankly, right now, since there isn't a negative involved, it probably wouldn't have mattered on my 8 there, but on the next one it will. All right, 2 times 8 is 16 plus 5, 21. 8 minus 3, 5, 21 fifths. Raise your hand if you agree. Okay, good. On the next one, would you put in this same function, except if I were you, when I was writing it, I would write 2 empty spot plus 5 over empty spot minus 3. Do you get why I did that? Put the empty spot in where the what was? The x. Good. And now I'm going to drop in a -7. And then it's totally fine with me if you can do the rest in your head, but at least you showed some work this way. So do the rest in your head if you can. Tell me your answer, turn it my way, and I'll see if you're doing it right. I think you have a negative issue. Although maybe there's 2 negatives. I think. No, you had a negative issue. A lot of you have a negative issue. Either that or I have a negative issue. Hold on. Let me check. Oh, okay. Some of you have the negatives and you just haven't canceled them. Do you get if there's 2 negatives, you need to cancel them? All right. So you had it right in the first place. I apologize. All right. Wait a minute. 9. Okay. Yeah, now I'm with you. Good. Got to fix it. Something's wrong with your top one. Good. Got to zoom in bigger next time, so I can't see the whole worksheet. Good. Okay. So it was 9/10, and it was actually -9 over -10, and that's where I was saying you need to fix those negatives, and it's 9/10. All right. The f of 3. Oh, for Pete's sakes, that's so easy. Let's move on. Look at this one. F of 8. Let me ask you the question this way. What's the input? 8. What did I tell you? Did I tell you x or did I tell you y? I told you x. So I told you x is 8. So you find 8, you go like this, right there. Oh, there's the spot. And it looks to me like it's about, what do you guys think, 4 or 5?
5.
All right. I could probably argue it, but I'm going to go with 5. That sounds fine. Maybe 4. F of -7. What's the problem with that? There's none on the graph, so I can't tell where it goes. Now, could I assume it might be heading towards 0 here? Not really, because it actually looks to me like there's an asymptote right here. Do you know what an asymptote is? Asymptote is a line you get closer and closer to and you never touch. So I'm guessing that the answer would be like 2, but we don't know because it's not on the graph. Next one's f of 3. That means stick in x is 3. Take a look close now. If 3 is right here, do you get that there might be nothing there? I would agree. I think that there's nothing there, so therefore there's no answer. Yes?
What happens if you did earlier with the 2 lines? Like, I don't really know how I'm trying to explain this, but like, what if you have the 2 lines on the graph and the same, like, what is that called? Like the quadrant?
A quadrant?
The quadrant?
Yes.
They're not crossing.
All right, here's 2 lines that are in the same quadrant and not crossing. Okay? What are you asking? Oh, is that a function or not? Here, I'll give a simple answer for you. Does it pass the vertical line test? No, because if I draw a vertical line, it's going to touch twice, right? Not a function. Now, could it be two separate functions? If you think of it as two separate things, could each of them separately be a function? Yeah, but if it's one thing, then it's not a function. It could be two separate functions. All right, moving on to this part. Example 2, given f of x equals 4x plus 9. Remember, what's f of x exactly like? You can replace f of x with what? Y. It's pretty much just saying y equals that. Then, find x when f of x equals 21. Once again, did I give you x or y on that one? Told you y. Y is what? 21. See, look in this equation here. Where is the f of x? F of x is 21. This is substitution. I can replace that with that. Here's that. I can replace it with a 21. And if you can't solve that, we need to move you back a class because this is algebra 2. That's algebra 1. Very easy solving. Don't even want to do it. Do you get it? Okay, let's move on. This one, f of x plus 9, or sorry, f of x is x plus 9. G of x is x squared plus 5. Find x when g of x is 14. Again, you got to ask yourself each time, did they tell me x or did they tell me y? Told me y was 14. Now, where is y? That's y. Now, if I put it in right here, I could be making a tragic mistake. That's f of x. They didn't say f of x was 14. What did they say? G of x is 14, so I'm putting a 14 over here. And I solve this one. That's a little trickier because it's got a squared in it. Go for it. See if you've learned anything from that top 20. Because if I hadn't done that top 20 right now, I bet you a lot of people would have the wrong answer right here. But I bet you a lot of you will figure it out. Turn it my way when you think you've got it. It's close, 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 close. We have work to do in the top 20, sadly. We're so close. Yes. Gonna be a fighter pilot, I can tell. Yes, yes, yes. So close. Yes, yes. Now you got it. Yup. Forgot something. Forgot something. Forgot something. Forgot something. Yes. Got it now? Zoom in on it. Nope. Thank you for trying. All right. Here's what you should be doing. Subtract 5 from both sides, and you get 9 equals x squared. Then you take the square root of both sides. And the easy answer is 3, but that's the wrong answer. Do you remember when you take the square root of something, you need to end up being careful if you ever do the square root of a variable. It's the absolute value of 3. If you hadn't watched the video on this one yet, you probably hadn't known this yet. It's off the top 20. And when you do the absolute value, you get two answers, plus and minus 3. Think about this now. I know you knew the 3 worked. But why would negative 3 also work? Because it's going to get squared. You see why negative 3 is exactly the same as 3, really? Once you square it? Okay, so that's why you need 2 answers. I know those of you that think it's 3 feel like you're being cheated here, but it's really important. If you have only one of the 2 answers, you can't get the credit. You have to have both, plus and minus 3. All right, good. Let's move on. The only thing that throws a wrench into that is that this is a function. And if it's a function and we graphed it, you'd end up having to rule out one of those 2 because otherwise it wouldn't be a function. It would have 2 outputs for one. No, wait. That's 2. Let me think. That's 2 inputs that give you the same output. And that's okay. So, yeah, that doesn't break the function rule. Okay, forget that. Sorry, that was a math teacher rambling moment. Ignore everything I just said right there. B, g of a. Okay, how about this? Do you at least know which function I should put it in? Which one? Yeah, the g function. This function. And I'm going to put in what? An a. Where do I put the a in this function? In for x. And it'll say g of a is a squared plus 5. That's it. Unless I tell you what a is. If I tell you a is like negative 5 or something, but they didn't say that. They just told you g of a. So you would write a squared plus 5. You drop in whatever they tell you to into the equation. So, okay, so g of a plus 1. Try to do it. See if you can do it without me. Circle it. when you're done. You do not have to multiply it all the way out. Yes, nice job. Yes. You're going to take that g function. Those that are kind of lost, take the g function right here and just copy it down, except leave an empty spot where the x should be. Empty spot with a parentheses, because remember how that's important with the negatives and everything? Okay, and then what am I going to drop into the parentheses this time? A plus 1. So g of a plus 1 is a plus 1 squared plus 5. There is your answer. That's really where the question was, see? So don't think of this as an equation. That's one of the worst things you can do. Don't think of this as an equation, or you're going to want to like divide by g or something dumb like that. It's not like that. You are just trying to find the answer, and this is the question, and that's the answer to the question. Could I have actually multiplied that out? A plus 1 quantity squared and then plus 5. Yes, I could have, but I told you not to because it saved time. All right, now here's the challenge one. The hardest kind of function one. Find m when f of m minus 2 is equal to 21. Remember, we're using the f function now. And my first advice is to write the f function with empty spots. F of empty spot equals 4 empty spot plus 9. Then, what did they tell us? Did they tell us x or did they tell us y? Tell us y. Y was what? So I'm going to replace the y. That's where f of x is, right? This is where y is, right? I'm going to drop in 21 right there. All right. Now, what am I supposed to put in for x? Isn't that where x usually goes? What are they telling me to put in? M minus 2. That look like an equation to you now? It's got just an m in it? So you'd solve that equation. Go ahead, solve that equation, and I'll see what it comes out to. Are you checking it now, or? Okay. All right. Gotta be done though, because it's timed. Okay. Cool. Thank you. And now, if you can get to the notes, that'd be good. It's on day 3 of the red chapter. The second. It's not algebra review. It's the one underneath that. Ah, a bunch of people have it now. Good. 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 And good, good, good. Oh, everybody's getting it right. I'm going to save time and say m equals 5. Those are a lot easier than the ones on the graph, aren't they? The ones on the graph were really complicated. But this, all you had to do was stick in the y and the x. And then you solve it. All right, moving on. This is a table. And calculus is kind of like math doesn't change that much over time. But how people teach math changes over time, and what kind of tests they put on the problem questions they put on the ACT changes over time. This is one of those things that's kind of changed a little bit. They do more and more tables like this. So we're going to be adding that this year. You'd never even know that it was missing last year. But anyway, we're going to be doing, you're going to see a fair amount of table stuff. So get used to them because they're here to stay. Did I tell you x or y? What? That's where the x goes. X is what? So right away, do you get where x is -1? Do you see it on the chart? Do I want where x is 0? No. Do I want where x is 1? No. X is 2, x is 3, x is 4? No, I wanted where x was -1. That's right here. Now, which of the two, it's just like a little logic puzzle. Which of the two functions do I want, f or g? F, and therefore the answer is that one. So it's 5. This is actually easier than rocket science by quite a bit. All right, so move on to the next one. On this one, B. Did I tell you X or did I tell you Y? It's kind of like Y. It's, G of X is like Y. Okay. So where's G of X equal to 0? Find it on the chart. And if I were you, I'd kind of do what I did. Just zero in on that one thing we know. G of X is 0. Where is G of X 0? Well, first of all, if I'm in G of X, do I want the F of X column? No. Do I want the X column? No. I only want the G of X column. Okay? And if G of X is 0, G of X is 0, is the X 0? No, the G of X is 0. That's this one. Now, what did I want? What did I want to know? I've got G of X is 0. Yes? Oh, is there another 0? Oh, cheating. Sorry. Thank you. There's 2 spots where G of X is 0. Thank you. Didn't notice that. Okay. What do I want to know? The X. So you could go up and figure out what X goes with it. The X that went with it is that. So I already had the zeros, so now I got 2 answers. The way you'd write this, by the way, is that X equals -1 and X equals 1. Why don't you think I want you to write it like that? -1, comma 1. Because it implies there's an X and a Y. And these are actually both X's. You don't want to write your answers that way, because it implies an X and a Y. All right. This next one. -2 f of 2. Always figure out what the function is doing. Okay, so we got to figure out f of 2. Anyway, back to recording. The f part of the function is the important part, so we're going to do the f part first. So, f of 2. Act like it's just a question of what's f of 2. F of 2, here's the f function, and f of 2, is it x being 2 or y being 2? X is being 2. Where is x2? It's right there. See where those two kind of overlap each other? What's the answer? 0. And then, if I put a 0 right here, do I do -2 plus 0 minus 0, what? Times 0. That's a times in there. -2 times 0 is 0. All right, on the next one on D. Figure out x when 6 plus f of x equals 4. Ooh, that's nasty. Did they tell us x or did they tell us y? Now, this one's trickier than all the other ones combined. X when is just telling they want to know what x is. Okay, so I'm going to get rid of that. Now I'm going to look at this a little closer. 6 plus something equals 4. Think about this. What does that have to be right there to make this little equation work? 6 plus what makes 4? So didn't they, by doing this, really tell you that f of x needs to be -2? Do you get what I'm saying? Because 6 plus -2 equals 4. So f of x, this part right here, has to be -2. Another way you can think of that is you can subtract 6 on both sides. All right. Now, f of x equals -2. Now, did they tell me x or did they tell me y? Tell me y. Y is really -2. So I'm going to find where f of x is -2. So I'm going to still use the same f of x function right there, and where it's -2, where x is -2 or where y is -2. Y is -2. This is the y. Y is what? -2? It's not on my list. All right, so that one is not a great example problem, sorry, because there's no answer for it. I'll be honest, I didn't make this smartboard, and I know whoever did is human, but I think they meant to give us an answer that would be on the chart. So let's say, let's imagine for a moment that this had come out to 4. If it had, then I would say, oh, y is 4 right here, and they want to know the x, because they told us the y. They'd want to know the x, and then that would be the answer. The answer would have been 1. All right? How about I change the problem just a little bit so that it'll actually work? So D as in donkey, got to remember to tell my colleagues this when they get to this smartboard. They should change that instead of if it was just 5 right here, change that 6 to a 5. Now try the problem if this 6 is a 5. Okay? Now pause for a second while you do that. So this one, when I make that change, now I'm going to subtract 5 from both sides, and I have f of x equals -1, and now I'm giving you that y is -1. See, this is like y. Y is -1. So I use this function right here, the same function I've had circled for a while, the f function, and then I'm going to find where the y is -1. The f of x is -1. It's right here, and what I want to know is what is x equal to. Here's the x column, and that's the one I want right there. The answer is 3. So x is 3. Okay, that's some tough stuff. So I think we've done enough practice on these. These are just going to make it a little bit more complicated each time. I want to make sure you get this. Look at the beginning one here. Do you get that you figure out f, you figure out g, and then you just multiply them? So you'd find f of 0, you'd find g of 4, and then you'd multiply them. So here's f of 0, which is 2. Here's g, I'll use green for that, g for green, of 4, and that's 4, and the answer would be 2 times 4 is 8. Raise your hand if you get that. Okay, good. Then the rest of these are like that. Figure out this, always find these first, and then I take the square root of whatever this was and divide it by that one. I'd start by finding g of x. Then I'd take -2 times that. And that should equal, oh, wait a minute. No, on this one, I would divide by -2 on both sides. And g of x equals 2. And then I just have to solve for that and try to figure out what x must be. All right. That's all we have. And I wanted to give you some time to work. That's why I went through the last part so quickly. So if you need help, you have time to ask me for help. If I just blah, blah, blah the whole time, you don't have time. So let's get to work. Work on your homework. I will be asking you in a minute for those scores in the top 20. And that's all I have for the video for today.